In this video, I'm going to go over benchmarking, which includes a discussion of constraints and criteria, and some talk about sketch hypothesis. So basically, benchmarking allows you as an engineer to evaluate multiple design solutions to really compare how these solutions rate um, across a set of criteria that you typically find from talking to your users or from different stakeholder groups. They can also be used to identify current standards, understand trends, inform continuous improvement, and maintain a competitive edge. You can also use benchmarking really early on in the design process, or you can use it later on as you're actually in the process of developing different designs and trying to decide on which design you want to take forward. The benefits of benchmarking is it sort of helps you develop a more quantitative way of making comparisons between different products. It helps you identify strengths and areas of improvement, for your design. Helps you improve the quality, better performance, and come up with ways of trying to find the most efficient product that you can. So it's something that is used by engineers. Constraints are quantitative, and their constraints are things that must be accomplished for a solution, for a design solution. Things such as, the examples here, must weigh under 1 pound, must cost less than $5 to produce, must be at least 75% recyclable, and must contain 3 parts maximum. So these are constraints. These are things like if it weighs 1.5 pounds, then you'll have to take it off of the table. That's not going to be a potential solution. So if something doesn't accomplish this constraint, it either needs to be eliminated or you have to redesign it so that it can meet those constraints. And notice that each of these have something quantitative attached to them. Criteria are more of what a solution should optimize. And examples of this are, the product should be as light as possible, or as inexpensive as possible, or environmentally friendly, or as few parts as possible. But you see, these are a little bit more qualitative, and they're things that you're just trying to optimize, trying to figure out what combination makes the best product that you can. So the chosen solution will typically be one that is sort of the best optimization across criteria. Um, so in this table, you can see sort of constraints versus criteria. So constraints are quantitative. They're about what must be accomplished with your solution, versus criteria are things that you should optimize. So examples, from the constraint side, must weigh under 1 pound versus a criteria, which is as light as possible. For the constraint side, must be at least 75% recyclable, and then on the right side is as environmentally friendly as possible. Um, so pre-benchmarking, for pre-benchmarking, you can do benchmarking pretty early on in the design process. And one way of doing that is to actually look at existing solutions, things that are already on the market. So if you're designing, say, a camp stove or something, you can look to see what other camp stoves are there on the market right now. What are some different camp stoves that might be popular in different countries, and try to get some variability in the different camp stoves that you look at. And this will help you become more of an expert into that product that you're designing. And it'll help you see how different companies have solved different problems for what you're trying to do. It also helps you sort of get more understanding of the context and the topic. Maybe with camp stoves, you'd learn that there are different ways of different fuels that you can use, and different sizes, and different I don't know, different capabilities, different heat, or the temperature may be different. Um, so and then it also helps you sort of learn to start sort of scrounging around for data and trying to find data whenever you can. So things like, cost, complexity, size, and safety. Potential sources. So when you start looking into these things, obviously the internet is a great one. You can do observations, you can do surveys, site visits, take measurements. So actually get the products in your hand or the solutions in your hand and actually take some measurements. Databases, scientific journals, depending on what you're designing, articles, regulations and standards, um, possibly, different articles, newspaper articles, magazine articles, books, and also interviews, interviews with clients or users or stakeholders or experts. So these are just potential information sources that you can use to do your benchmarking. So for the steps for benchmarking, you first want to identify the constraints and criteria against which you will evaluate existing solutions. For each constraint or criteria, you want to identify the metrics by which you'll evaluate each solution. So it might be weight, and you're going to be looking at pounds, cost, the amount of money per unit, or number of dollars per unit. Environmental friendliness could be percent recyclable, although there could be a lot of other things that you measure for that. Complexity, number of parts, that sort of thing. And then for the, you also want to select a rating scale. So from 1 is the worst to 5 is the best, or whatever your rating scale is. It could be a 3-point rating scale, depending on what you're doing. And then you want to evaluate each of the existing solutions against your chosen constraints and criteria. And then at the end, and remember, this is not something to have like this magical formula that'll tell you what you need to design. This is just something that you can use to help you think more deeply through your design process and as an engineer. So you don't want to just take what outputs from the tables, because you're the one that put all the input into it, and there's obviously some subjectivity inherent in those. So you want to think about like interpreting what the solution is that you come up with, and draw some conclusions. But there is some interpretation in this. So what solutions meet each constraint and which do not? For each criterion, which ranges do solutions tend to fall in? And then which solution is best, worst on each criterion and overall, and why? And so this is just trying to get you to think, do some interpretation as the engineer. Like I said, you aren't just going to output the benchmarking and say, okay, this is our solution. But you want to think about what this actually means. Here's an example benchmarking table. This was for filtration devices. And so you can see, we pulled up, like a LifeStraw, ceramic clay water filter, LifeSack, and water purification bike. And then you can see the costs, the efficiency, the availability, how much water is produced, and then the life cycle. And then you can see the 1 is the worst and 5 is the best. So LifeStraw is the best, or rated the best for cost, so $4 per straw, whereas the water purification bike is rated the worst for cost at $6,700 a bike. And then you can see where those sort of flip-flop when you go under the produced column in the table, where the LifeStraw is actually the worst, number 1, so approximately 1,000 to 18,000 liters. And then, I guess it's over the lifetime of the straw, so over 1 to 2 months. And then for the water purification bike, you can get up to like 1.3 gallons per minute. So that would be the best for the water production from it. So that just shows sort of an example. And you'll be going through an activity in class doing this, where you'll identify certain solutions and then you'll make decisions. The next step will be to start to sketching some of your hypotheses. So trying to understand like how do things work. So in that example, if you were doing the water filtration devices, trying to figure out how those actually work. The example here on the right side of the slide is a mouse that you use for a computer. And so doing some sketching to try to understand what's actually going on inside of the mouse. So sketch hypothesis, sketch of the imagined inner workings of a product or design solution. In the case of the project that y'all are going to be working on, you're going to be sketching or trying to hypothesize how the electric toothbrush actually works. And in this sketch hypothesis, you want to focus both on the internal and external components and parts and how they function relative to each other. So that's it for this presentation, and let us know if you have any questions.